Light emerging from black holes when they collide. Stay tuned to know more. Welcome to TechieSpod, where you will get all the information on interesting topics and blogs on it to read. If you are not subscribed yet, then you are missing out something. So, here we go. Black holes aren't supposed to make flashes of light. It's right there in the name, black holes. In recent observation, it is found that in space, when two black holes collide, they generated light energy. Isn't it shocking? Let's see more on this. A black hole is a region of spacetime where gravity is so strong that nothing, no particles or even electromagnetic radiation such as light, can escape from it. The theory of general relativity predicts that a sufficiently compact mass can deform spacetime to form a black hole. The boundary of the region from which no escape is possible is called the event horizon. Although the event horizon has an enormous effect on the fate and circumstances of an object crossing it, according to general relativity, it has no locally detectable features. In many ways, a black hole acts like an ideal black body, as it reflects no light. Moreover, quantum field theory in curved spacetime predicts that event horizons emit Hawking radiation, with the same spectrum as a black body of a temperature inversely proportional to its mass. This temperature is on the order of billionths of a Kelvin for black holes of stellar mass, making it essentially impossible to observe. Astronomers have apparently seen the invisible. They have observed a collision between two black holes. Such an event is invisible, usually. However, a massive black hole sitting close by two black holes in deep space helped illuminate the other two as they collided and produced a burst of light. If confirmed, the findings, published in Physical Review Letters, would be the first optical observations ever made of a black hole merger. If confirmed, according to the findings published in Physical Review Letters, this event would be the first ever optical observation ever made of a black hole merger. On May 21, 2019, Earth's gravitational wave detectors caught the signal of a pair of massive objects colliding, sending ripples cascading through spacetime. Later, an observatory called the Zwicky Transient Facility (ZTF) caught a blast of light. As scientists looked at the two signals, they realized both came from the same patch of sky, and researchers started wondering whether they had spotted the rare visible black hole collision. This detection is extremely exciting, Daniel Stern, co-author of a new study on the discovery and an astrophysicist at NASA's Jet Propulsion Laboratory in California, said in a NASA statement. There's a lot we can learn about these two merging black holes and the environment they were in based on this signal that they sort of inadvertently created. Scientists suspect, based on the pairing of gravitational waves and light, that the flare sprang from two small black holes merging within the accretion disk of the supermassive black hole. The supermassive black hole's incredibly strong gravity affects the smaller stuff in the disk, even other black holes. These objects swarm like angry bees around the monstrous queen bee at the center, co-author K.E. Savick Ford of the City University of New York Graduate Center, the Borough of Manhattan Community College and the American Museum of Natural History, said in the statement. They can briefly find gravitational partners and pair up, but usually lose their partners quickly to the mad dance. But in a supermassive black hole's disk, the flowing gas converts the mosh pit of the swarm to a classical minuet, organizing the black holes so they can pair up. The flash of light doesn't come from the merger itself, the scientists think. Instead, the force of the merger sends the now a little larger black hole flying off through the gas surrounding it in the supermassive black hole's accretion disk. The gas, in turn, produces the flare after a delay of days or weeks, the theory goes according to the statement. In the case of this event, scientists detected the flare about 34 days after the gravitational wave signal. That's not a guarantee that this explanation fits what happened, the researchers said. The flare occurred on the right timescale, and in the right location, to be coincident with the gravitational wave event, Graham said. We conclude that the flare is likely the result of a black hole merger, but we cannot completely rule out other possibilities. So, guys, that's all about this topic. Don't forget to like, share and subscribe. That's all for this video. I hope you all like it. Please follow us on Instagram, Facebook and Twitter. The links for the following are given in description. Thank you.